Okay, now let's see what we mean by f of 3. Now y equals f of x. What does this mean? This means you put a value of x into this rule f of x, whatever the rule happens to be. And the rule in this case is basically just this graph. So if you have a value of x, you put it into the rule and you get the associated value of y. And in terms of this graph, this means that f of 3 is the value of y at the point where x equals 3. The graph point where x equals 3, well, we usually find that. We just project ourselves up to the graph. And right there is the point that we project over to get our value f of 3. So if this is 3, we go up to the graph and over, we get the value of f of 3. What is a line segment whose length is equal to f of 3? Well, actually we have two of them sitting here waiting for us. We have the line segment from here to here and the line segment from here to here. And if we wanted to draw any line segment from the x-axis vertically up to this dotted line, this projection line here, it would also have length f of 3. Now, keep it simple. I'm just going to say length f of 3, this segment right here. Okay, now what about length f of 1? Well, you should think about this. You shouldn't let me do this, because once people had this hint, they were off and running. Of course, if you've already gotten it, that's great. F of 1. Okay, first thing we got to do is locate 1 in this graph. Now, compass and straight edge wouldn't help you a lot here because you can't trisect a line segment, although you could approximate 1/3 of this distance using a lot of subdivisions. We're just going to eyeball it, 1, 2, 3, so I think 1 is about here. We're just trying to draw representative line segments on the graph, so it's okay to use a rough estimate. So right there is a line segment of length f of 1. Okay, that would be this segment. And of course, f of 1 is the value you get here on the y-axis. So there's a line segment of length f of 1. There's a line segment of length f of 3. Okay, what about f of 3 minus f of 1? Again, if you haven't already gotten this, you should pause and ponder it until you get an idea. Okay, well, one thing I saw that's totally incorrect, and I can show that it's incorrect, is that f of 3 minus f of 1 ought to equal f of 2 because 3 minus 1 equals 2. Not a total unreasonable thing to conjecture. So people would get the point 2 and tell me that this line segment had length f of 3 minus f of 1. Unfortunately, that's not correct, but the distributive law doesn't apply here, and actually we have a theorem that we can get out of this that I'll state here in a little bit. And basically the theorem just says that f of 3 minus f of 1 would equal f of 3 minus 1, which is of course f of 2, if a line between this point, the x equals 3 point, and the x equals 1 point extended would pass through the origin. Okay? Then you could actually say that, but that's a very rare circumstance. There's no reason to expect that would happen. So we'll probably state that shortly. But how do you do f of 3 minus f of 1? Well, f of 3 is the length of this thing, f of 1 is the length of this thing. How would you get the length of this minus the length of this? You could project over here. So here's the length f of 1. This length is f of 1. This length is f of 3. So f of 3 minus f of 1 would correspond to the length of this minus the length of this, which would be the length of just this segment. So this segment would have that desired length. Or if you wanted a segment here or any segment between this projection line and this projection line would have the same length. Okay? So, we have that. Now, I suggest that you give this a little more thought if necessary. I'll do that in another video.